Hello, what's up, everybody? Now I'm working on modeling of a well that will be worked over, and the worked over will be about adding perforation. Okay, so I have a well, and this is the dashboard. I have a well. This well is open, currently open, perforated at a certain flow unit, at a certain perforation interval, and then I just want to add perforation. I will add the perforation at the top section of the reservoir. Basically, I want to target the attic oil zone. So I will just add perforation to the top of the perforation. Okay, so this is the model, as you can see. So I think let's go ahead to check the fluid parameters. So this is the fluid parameters. You can see the oil specific gravity 0.8, gas specific gravity 0.7, and yeah, but the main thing is in here, the reservoir section. Okay, I just call the reservoir the reservoir. This is the reservoir pressure, temperature 180. This is the current middle perforation, and the mid perf later on will change because I want to add perforation, and the current water cut is 97%. This is the gas oil ratio, and I want to model, or sorry, the current IPR modeling is done using Vogel equation with Vogel coefficient of 0.2, and the productivity index is 20 stock tank barrel per day per PSI. Okay, so this is the current, the actual or the existing productivity index. And of course, the productivity index will change because I want to add perforation. I want to add perforation at the same reservoir. So the productivity improvement will come from reduction of the partial penetration skin. Okay, so because I currently do a partial completion, I only perforate a certain fraction of reservoir. I will have, or I currently have high skin due to partial penetration, partial completion, right? But if I add perforation, I will reduce the skin due to partial penetration, and the productivity index will increase after the workover. Okay, but to model the improvement or to capture the improvement, I will first create an analytical model that will mimic this existing performance. Okay, you see in reservoir layers data, currently this IPR is generated using manual option. So in manual option, we just input the pressure, temperature, middle perforation, water cut, and GOR, and the productivity index directly inputted in this manual section. In test data, you need to provide with the well test pressure and well test rate, and then the productivity index will be calculated. Okay, but in manual or in test based, there is no skin calculation. Okay, there is no skin calculation. There is no skin due to partial penetration. Okay, so if you want to model the decrease of skin due to partial penetration, you cannot do that in manual or in test data. So you first need to model in layer parameters. And in WellFlo, layer parameters means the IPR will be generated using theoretical or analytical means with analytical method. And in this analytical method, you can involve skin. Okay, so my plan is to first generate an analytical model that will mimic this productivity index. Okay, I want to create the analytical model using the real data from this well, from this reservoir, that will target the productivity index of 20 stock tank barrel per PSI. Okay, so I can name it existing, Okay, and I will create a new reservoir and I will call it match existing. Okay, so I want to make an analytical reservoir using layer parameters that will mimic the existing or the real reservoir. Okay, so I will apply and I will save. I will be careful here. Okay, I will check the pressure and temperature. Okay, the pressure is this one, temperature this one, mid perf 2770. Okay, in existing, not in reservoir. I will rename it as existing and we'll call it as existing. Okay, now I will go back to the match existing layer parameters. The pressure is this one, the temperature 180 degrees Fahrenheit, mid perf is 2770. Now the permeability will be imputed with log data. I will check my log data first. The log data is 100, okay, and the thickness is 56, available radius 0.4, relative injectivity no, because it's a production well, water cut 0.97, okay, and then the GOR is 300 SCF per STB. Fogel equation with coefficient of 0.2, and then drainage area geometry, assuming the equivalent drainage radius of 250 meters. Okay, it's a rule of thumb for oil well. If you are not so sure about the exact or the actual drainage radius, actually you need to predict the drainage radius from pressure transient analysis or just from structural boundaries like fault or adjacent wells. Okay, but if you don't have any certainty, you can model it with 250 meters for oil and 750 for gas. Okay, click apply, go back to general. Now we need to include the skin. So use calculated skin tick and input the skin, completion type case hole. And now you see we have damaged skin, limited entry skin, deviation skin, and crash zone skin or skin due to perforation in this step. Basically, I can skip damage skin because I don't have any certainty regarding that. I don't know the damage zone permeability. I don't know the thickness. I don't know the damage zone skin. Okay. You can know that if you do laboratory job, but on the field, it's impossible you can know that for quite high confidence. So, and again, the limited anti-skin will be significantly bigger than damaged skin. So we can just concentrate on limited entry skin, deviation skin, and perforation skin. Okay, and then for this one, I need to input the nearest measured formation distance or distance to top boundary or bottom boundary. In this case, I have measured that, and the nearest boundary is located at 24 feet from the current perforation. Okay, and actually the mid perf is located at 2786. 2786. I need to correct that. 2786. Apply, and in the existing, I will also correct that 2786 here. 2786. It will not influence the absolute open flow, but yeah, just to make sure that it's correct. Go back to analytical method, the match existing. layer parameters, okay, and then go back to skin tab. Vertical permeability, I'm not so sure, so I will just predict it to be 10% of the horizontal permeability. The horizontal permeability is 100, so the vertical permeability is 10, and open interval before the before the workover, the the open interval is, let me calculate it, 8, only 8 feet, which will give me limited entry skin of 20, which is quite big. Okay, well deviation, it's a vertical well, so it's 0. If it is a vertical well, then there is no skin due to deviation. If it is a deviated well, then you will have negative skin, which is good, but it will not be big. Okay, perf diameter 0.37 inch. Okay, and then shot penetration in inches 39.6, quite long. And then shot density 5 shots per foot, shot facing 60. I will calculate using log flow shape factor, which will give me minus skin due to perforation. Okay, as you can see here, the productivity index is only 1.7. So if in reality, based on measurement on the field, the PI is 20, just like what we have in existing tab, the real data. So maybe the permeability from the log is not representative, because you see the depth of investigation of log measurement is only several inches to some several feet. It will not be deep enough. But yeah, the productivity index is governed by a producing area that is kilometers in size. Okay, kilometers in size, or hundreds of meters in size based on the drainage radius. So 100% based on log will not be representative to represent the the overall drainage area of this well. So I can adjust the permeability so that I can get, or so I can match the productivity index, so I can achieve productivity index of 20. So let's start with a big leap, 1000. What will happen? You can only improve the productivity index to 9. But if it is 1000, then the vertical permeability should be 100. Then you can achieve 16.7 productivity index. So actually the permeability is very high, 1000. Okay. Or maybe there is also some issue with thickness, 56. Let me check again if 56 is the correct number. Let me check on my data. Yeah, we can play with that. I think what about 60? You see, playing with thickness is not very significant. 70, only 16.9. Okay. So the most important thing is playing with permeability, 1200, and it will be 120. Okay, so now you can get productivity index of 20.3. Okay, I will reduce the permeability 100 to 1115, and this will be 115. So now you get 18.99. So I will increase again. This kind of manual matching is not bad actually. 150. should be, yes, yeah, it is, it should be 11880. Okay, 1175. Okay, and then this should be 117.5. Okay, should be 1.8. Yeah, should be 1.80 or 78. It's funny. 7.8. Okay, 19.99, which is practically 20. So I will click save. So now, assuming the other parameters are correct, so the permeability of this well should be 1178. Or maybe to make it more conservative, I will reduce the drainage radius to be 200. Okay, and then I will lower down the permeability. Still, you can play with this because there is no high certainty regarding this drainage radius. Okay, or 65.5. Okay, or maybe let's go back to 250 because it's a rule of thumb and the number is better actually. So basically the permeability is high. Okay. So now the representative permeability is 1178, not 100 as per the log data said. Now I will save and then I will create the model which I will call after job or after the perforation. So after the perforation, what will happen? Of course, the skin due to partial penetration will change. The skin due to partial penetration will change, will decrease. So I will get higher productivity index at the end of the day. But the pressure, temperature will be the same. Okay. So it is, I think this one, 80, 834.7, 180. Permeability is 1178. Thickness 56. Wellbore radius the same, 0.4. Water cut the same, 0.97. Gas oil ratio 300. And then drainage radius the same, 250. And then the same, we will model it with Vogel efficient of 0.2. Mid perf will change and the mid perf will go up because we will add perforation to the top of the reservoir, and it will change to 2778.5. 2778.5. Not too far away from the existing perforation. Okay, click apply. And now we will deal with this skin. Go to skin, case hole. We will input the limited entry skin, deviation skin, and perforation skin. Now with additional perforation, okay, I will locate the new or the added perforation interval close to the top boundary. Then the nearest measured formation distance is now 0. Vertical permeability the same, 117.8, which is 10% of the horizontal permeability. And now the open interval is 28. So I will add 20 feet perforation interval plus the existing 8 feet perforation interval. So the total is 28. So now you see the limited entry skin decreases significantly from 20 in the previous model to only 4.7. Okay, so the workover gives me an important decrease, a big decrease of partial penetration skin. Deviation skin, there is no skin for deviation because it is a vertical well. Perf diameter 0.37, again the same. Shot penetration 39.6, shot density 5, shot facing 60. So the same for skin due to partial penetration. And now you see, now the productivity index becomes 47. 47. It's a huge improvement. Huge improvement. Okay. From 20 stock tank, from 20 productivity index, stock tank barrel per day per PSI, by reducing the skin due to partial penetration, now I can get productivity index of 47.1482. Okay, so I will click save. So you see, this is the result. This is the result that you will get if you reduce skin due to partial penetration by adding perforation. So if I plot all the IPR, show composite IPR, I will not include this because this is a total IPR by combining all the IPRs. Basically, we don't add up reservoirs in this example. I just change the skin. So to avoid misleading, I will color it as white so we can only focus on this section. I will change the properties and change it to maximum 25,000. Okay, or okay. So these two IPRs close here is actually the real IPR from productivity index of 20 and the analytical IPR that I construct to mimic the actual IPR. And then I reduce the skin due to partial penetration by adding perforation. Now I can get new IPR here, which is very big. Okay, so yeah, that will happen. So now to create the nodal analysis, I will deactivate this one. I will deactivate the match existing because the latest or the new IPR will be based on the after job. Click apply, save. And with this ESP already installed, I can go to analysis. Okay, you see the ESP here already installed in the model. So I can click set range and then I will create the rates from 1% to 99% of the AOF, auto range, click OK. With this outlet node, wellhead pressure, click apply, click calculate. I can get the nodal analysis or should be the flow curves. Something, yeah, I need to rework the ESP section. Yeah, the ESPX section, I will need to rework it. But basically, the main job is about here in reservoir section. Okay, so by reducing skin due to partial penetration, by doing workover, I can significantly boost, increase, improve the productivity index. So at the end of the day, I will increase my oil production rate. Okay, I think that's all. I hope you enjoy the video. I hope this video is useful maybe for your project, for your case, for your study. And see you again in the next WellFlow videos. Thank you.